Hello everyone. Today I will explain you how to select the right heat exchanger for cooling the electronic system. And to select the right heat exchanger, first we need to calculate the heat exchanger capacity. And the formula for calculating the same is internal heat load minus heat transfer. The whole term is divided by temperature difference. As we all know, internal heat load is nothing but the wasted heat that's come out from the electronics component. Most of the time, the internal heat load is given by manufacturer and you will find on the data sheet. So if not, there are many formulas are used to calculate the internal heat load. So let us take one example how to calculate the internal heat load. An electronic system uses 14 components that draws 115 volt AC at 15 ampere. Each has a rated efficiency of 90%, and if we put it in another way, 10% each device is inefficient. The unused power becomes generated heat and thus the estimated internal load is. So, to calculate the internal heat load, first we need to find out the what is the power that is consumed by the electronics, and we need to subtract with the component inefficiencies. So, since our device uses 115 volt and 15 ampere, so we got the device power by multiplying the voltage with the current. And since we have 14 component, so we need to multiply it with a 14. So as we all know in this problem, the device or the component is 90% is efficient. That means 10% will be generating heat. So the whole term will be multiplied with zero point 0.1 and the whole term generated power. So total heat load is coming out 2415 watt. Since we have already got the internal heat load, now we will try to get the heat transfer load. So the heat transfer load is nothing but the heat transfer which is happening in the our metallic enclosure with the outside surrounding. Here in heat exchanger recognition, since this heat transfer is happening with the surrounding, that is why we have subtracted with the internal load. If it will be a air conditioned system, then this heat transfer load will be added in the whole term. So that is why the heat transfer is automatically happening. That is why we have subtracted here. So now how to calculate the heat transfer for this indoor application? So first, we need to calculate the surface area of the cabinet. Then we need to multiply heat transfer per foot square or in meter. So this is the chart that we will be using to calculate the heat transfer load. So now let us take one example. A painted steel cabinet has a 80 feet square of surface area and will be located in a maximum ambient temperature of 95 Fahrenheit. The rated temperature of the electronics is 75 Fahrenheit. So first we need to figure out the delta. What is the temperature difference? So we are getting a delta temperature difference of 20 degree Fahrenheit. So here this delta difference is given in Fahrenheit, and on the right hand side the delta is given in the Celsius form. In the top the we have watt per square meter, and in the bottom watt square foot. Since in this problem the area is given in the foot, so we will be figuring out in the watt square foot unit only. So corresponding to delta difference of 20 degree Fahrenheit, we will consider this curve for painted steel. In the problem, they have mentioned the painted steel cabinet, so we'll be looking for this darker curve. And corresponding to 20 degree Fahrenheit, we are getting a 4 watt square foot of this magnitude value. So that is why we have multiplied the total heat transfer load 80, which is the surface area, and with 4 watt foot square. So we are getting 320 watt. Now let us go to our first sheet and try to put the internal heat load and heat transfer in our main formula. So when we'll put the internal heat load 2415 minus heat transfer load 320, and the whole term is divided with the temperature difference of 20 degree Fahrenheit. Heat exchanger capacity is 104.75 watt per degree Fahrenheit. So now using this term, how we'll calculate the or how to recognize our heat exchanger will be, we need to visit this Danthram cooling system and we need to select for thermoflow. So here we will find many heat exchanger. So let us take this thermoflow 120. Now download the specs. So the heat exchanger, the capacity is given by cooling capacity. So the cooling capacity is coming 120 watt per degree Fahrenheit. And in our problem, the heat exchanger capacity is 104.75. So this system is sufficient to handle that much load for cooling our electronics. So this is how we can select the right heat exchanger for cooling the electronic system. Kindly consider subscribing my channel to know more about the mechanical design and CAD design. Thank you.